This is for all the cowboys out there.
It's time for Maths with Mr. Thomas.
Chapter 13, lesson number 3, the Euclidean algorithm 2, expressing the greatest common divisor in terms of A and B. Now, in the last lesson, what we were doing was using the Euclidean algorithm to find the greatest common divisor, or highest common factor, of two integers. What we can also do, though, is we can express this greatest common divisor of the two integers, let's call them A and B, as a linear combination of A and B. What that means is we can take that greatest common divisor of A and B and we can write it as something times A plus something times B. And we will do that through 3 examples. So example 1, use the Euclidean algorithm to show that the greatest common divisor of 149 and 139 is 1. That's just what we were doing in the last lesson. And then the new part, hence find the integers x and y such that 149x plus 139y equals 1. So to start this off, what we want to do is we're wanting to just show that the greatest common divisor is 1. And the two numbers that we have are 149 and 139. So you know what you want to do is start with the larger number, the 149, and write it in terms of the smaller. So we're going to have 149 equals 139 times something plus something. Obviously, there is just one 139 that will fit into 149, but we will have a remainder of 10. What I'm going to do beside that is I'm going to call that line 1. After that, what we do is we take this 139 and we write that in terms of the remainder. So we're going to have 139 equals 10 times something plus something. So obviously with the 139 you can fit in 13 tens, so it'll be 10 times 13 and you'd have a remainder of 9. And we'll call that line 2. Now we take the 10 and we write that in terms of the remainder. So we're going to have 10 equals 9 times something. Well, 10 is going to be 9 times 1 with a remainder of 1. Perfect. And we're going to call that line 3. Well done. We then take the 9 and we write that in terms of, again, the remainder. So we write that in terms of 1. So we'll have 9 would equal 1 times, and it's obviously 1 times 9. The remainder this time will be 0. Perfect. And because there is a remainder of 0, we stop. You notice here that we're calling this line 4. Make sure that you have line 1, line 2, line 3 and line 4. You will need that for the next bit. What is the greatest common divisor then? Well, it's just going to be the last non-zero remainder. This is all the remainders, 10, 9, 1 and 0. And the last one that was not 0 was 1. So you can say the greatest common divisor is 1. And again, the way you write it is you put the two numbers in brackets with a comma between them. What we now do for the second part, hence find the integers x and y such that 149x plus 139y equals 1. What we do is we repeatedly substitute expressions for the remainders in lines 1, 2 and 3. Let's do that over the page. So this is what we had just on the last page. We had all of these lines 1, 2, 3 and 4. What we do is we're wanting to start not at the bottom with the 0 as a remainder. We're wanting to start with this line 3. Start with where we had the greatest common divisor. The greatest common divisor is 1, that's line 3, so we start with line 3. And what we want to do is we want to think about rearranging this. If we had to write this greatest common divisor as that equals, well, we could say then that if we subtract the 9 times 1 from both sides, we would have this 1 equals 10 take away the 9 times 1. Or in other words, 1 would equal 10 take away 9. That's all we can do with that. We have the 10 take away 9. We can't really do anything else with it. So now what we do is we go up to line 2. And on line 2, you want to think, right, well, with that, the remainder was 9, so you want to find a way of writing the 9. So from here we can say that the 1 would equal 10 take away, and we can replace 9 with what it's equal to. And 9 would equal, well, to get the 9 on its own, we'd have to subtract the 10 times 13 from both sides. So on the left hand side we'd have 139 take away the 10 times 13. Because we're multiplying that by 1, we don't need to write it. Can we do anything else with that? Well, yes, we can. Because we've got the brackets here, we can multiply them out. There's nothing in front of the brackets there, so just imagine a 1. So we can say that 1 would equal 10 take away. Well, it's going to be 1 times the 139. So we just write that as 139. And it's the negative 1 times the negative 10 times 13. So the negative 1, the negative 10 will make it plus 10 times 13. If you look here, what then we've got is we've got a 10, and then we're going to be adding on 13 tens. So if we've got 13 tens and we add on another 10, well, we could simplify that, and we can say that that would be 14 tens, or 10 times 14. And again, we're still taking this take away 139. Can we do anything else with that? Well, no, we can't. We cannot simplify that. So now we go up a line to line 1. With line 1, again, take this remainder. The remainder here was 10, so we can rewrite any 10s. So we can rewrite this 10 here. How do we rewrite 10? Well, we're going to swap 10 with the 149, take away 139 times 1. Or really just 149, take away 139. So we can say 1 is equal to, replace 10 with, subtract 139 times 1 from both sides, and it'll be 149, take away that 139 times 1. Because I'm timesing it by 1, I'm just writing it as that. That's me rewriting 10. I'm still multiplying that by 14, and I'm still taking away that 139. Once again, because we have brackets here, we can multiply them out. So we've got what's in the brackets, we're multiplying by 14. So we know if we multiply that, we would have 14 times the 149. So 149 times 14. And we're taking away the 139 times 14 as well. And on the end, it's take away 139. Can we do anything with that? Can we simplify anything? Well, if we look here, we've got 139 and we've got 14 of them, but then we're taking away 139. So we're already taking away 14 139s, and we're taking away another one. So with 149 times 14, that stays as it is. But we're taking away 14 lots of 139. We're taking another one away. So really it's taking away 15 lots of that 139. Can we do anything with that? Well, no, we've reached line 1. And what we've got is we've got the 149 and the 139. They were the two numbers, A and B. And what we're really wanting in the question is we're needing 149 times something plus 139 times something equals 1. So rearranging this, what we would have is 149 times 14. That's what we want. And then we're going to have 139 times by the negative and the 15. So it'll be 139 times negative 15, and that would equal 1. From there, well, you can see that the 149 has been multiplied by x, and here we're multiplying by 14. So we know that x is going to be equal to 14. The y, what do you think the y is going to be equal to? Perfect. It's what we're multiplying the 139 by. And we're multiplying the 139 by the negative 15. So you can say the y would equal negative 15. And that's your answer. Example 2. Use the Euclidean algorithm to find the greatest common divisor of 1147 and 851. And part B, hence find integers x and y to write this greatest common divisor in the form 1147x plus 851y. So, to start this off, the same as the last lesson, we take the larger number, 1147, and we write it in terms of the smaller number. So the smaller number is 851. How many 851s fit into 1147? It's just one. Good. So it's going to be 851 times 1, and we would have a remainder of 296, and we call that line 1. What we then do is we take the 851 and we write that in terms of the remainder. So we will have 851 equals the 296 times by, well, how many 296 can you fit into the 851? If you used a calculator and divided, you would get 2 point something. So you know there's going to be 2. Work out 2 times 296. Work out what you add on to make 851, and it's 259. And we call that line 2. From there, we want to take the next number, so take that 296 and write that in terms of the new remainder. So 296 will be equal to 259 times something. That there, you could just fit in 1. And you would have a remainder of 37. Perfect. And we call that line 3. We now take the 259 and we write that in terms of 37. So we will say 259 equals 37 times something plus a remainder. If you work this out, 259, if you divide that by 37, you end up getting 7 exactly, which means it's going to be 37 times 7 plus a remainder of 0. And we call that line 4. Because the remainder is 0, we stop, and the greatest common divisor is that last non-zero remainder. And the last non-zero remainder was 37. So that will be the greatest common divisor. For part B, what we now want to do is we want to find integers x and y to write the greatest common divisor in the form 1147x plus 851y. And to do that, we repeatedly substitute expressions for the remainders in the lines 3, 2, and 1. So doing this over the page then, this is what we just had on the last page. This is the lines 1, 2, 3, and 4. And what we do is we take the greatest common divisor from line 3. So using line 3. We want the greatest common divisor of 37 to be 37 equals, and we want to find what it's equal to. Well, 37 is equal to get the 37 on its own, we would have to subtract that 259 times 1 from both sides. So we can say the left-hand side here is 296. So we know it'll be 296 take away, and we're going to subtract the 259 times 1. Obviously, when you multiply by 1, it just stays as it is. So 37 will equal 296 take away the 259. Just double check that, it does make sense. Can we simplify that? Well, no, we can't really do anything with that, so we go up to the next line. And in line 2, the remainder was 259. So what we can now do is we can replace this 259 with whatever it's equal to. So we can say from line 2, 37 is going to be equal to 296 take away. And if we think about the 259, we can get that on its own by taking 851 and then subtracting two lots of 296. So it will be 851 take away the 2 times the 296. That will leave us with the 259 just on its own here. 851 take away the 296 times 2. Can we simplify any of that? Well, yes, we can. If you imagine just a 1 in front of this bracket, or really a negative 1, well, what we've got, if you tidy that up, we would have 37 equals 296 isn't changing, but we're taking away one lot of the 851, so really we're just taking away the 851, and we've got the negative 1 times the negative 296 times 2. Well, really, the negative 1 we'll make that positive because we're multiplying it by a negative, and we would have the 296 times 2. After that, can you gather anything together? Well, yes, you can see you've got a 296 here, and you've got 296 here. So if we've got 2 of them here, 1 of them here, well, overall, we would have 3 lots of 296. And we're still taking away the 851. After that, can we tidy that up anymore? Well, no, we can't. So we go up a line now. And now we've got the 296. And we want to swap that with what it's equal to. So here we've got 296. And we want to swap that with, well, to get the 296 on its own, we would have the 1147 take away this 851 times 1. So from line 1, we can say 37 would equal, and replace 296 with 1147, take away 851 times 1, or just take away 851. You know, from that we are multiplying that by 3, so make sure you write in times by 3, and then we're taking away 851. After that, multiply out the brackets, so we'd have 3 times this 1147, and we're taking away the 851 times 3 as well. So take away 851 times 3. And again, we're taking away another 851. Gather your like terms. Well, you can see that you have taken away 3 lots of this 851, and we're taking away another 851. So really what we would have is 37 equals, well, I suppose the 1147 times 3 is not changing, that will stay as it is. But here we're taking away 3 851s, we're taking away another 851. So how many are we taking away? Well, we're taking away 4. So it's going to be take away, and we would have 4 lots of the 851. We know what we were wanting to do was express the greatest common divisor in the form 1147x plus 851y, so we just need to put it in that form. So we can say it will be 1147 multiplied by 3, that's not really changing, we're leaving it as that, plus 851 times by, and what are we multiplying it by? Well, you can see that 851 is being multiplied by 4, but we've also got the negative. Put them together and you would have negative 4. And that would obviously equal that greatest common divisor of 37. From that then, getting the values of x, you can see that x is going to be 3 because it's what we're multiplying the 1147 by, and the y would equal negative 4 because that's what we're multiplying the 851 by. Woo! Example 3, use the Euclidean algorithm to show that the greatest common divisor of 231 and 17 is 1, and then hence find integers x and y such that 231x plus 17y equals 1. So, to start this off, using the Euclidean algorithm to prove that the greatest common divisor is 1, start with the larger number, 231, and write it in terms of the smaller number, 17. So we can say that 231 is 17 times something. To find the something, divide 231 by 17. If you do that, you get 13 point something, which means there will be 13 17s that fit in exactly. You would then have a remainder of, well, you've got a remainder of 10 if you work that out. And we would call that line 1. After that, we take this 17 and we write that in terms of the remainder of 10. So we would say that 17 is going to be equal to 10 times something. That would be 10 times 1. And you would have a remainder of, perfect, remainder of 7. And we call that line 2. We now take the 10 and we write that in terms of the new remainder, which is 7. So we would say 10 would equal 7 times what? Well, that's 7 times 1. And you've got a remainder of 3. Perfect. And that would be line 3. Excellent. We then take the 7 and we write that in terms of the new remainder. So we write 7 in terms of 3. From here we can say that 7 would equal 3 times, well, what would that be? Well, it's 2. You can fit 2 3s into 7, but you would have a remainder of 1. Brilliant. And we call that line 4. After that, we would take the 3 and we write that in terms of the new remainder, which is 1. So we are going to have 3 equals 1 times 3, and you would have a remainder of 0. Woo! We can now stop. We've got a remainder of 0. And we call that line splunky-doink. No, we call it line 5. Because the remainder is 0, we stop, and the greatest common divisor is the last non-zero remainder. And you can see all the remainders here, 0, 1, 3, 7 and 10. And the last one that wasn't 0 was 1. So that is us proving that the greatest common divisor of 231 and 17 is 1. What we now do for the second part is we repeatedly substitute the remainders in line 4, 3, 2 and 1. So let's do that over the page. So we need these lines 1, 2, 3, 4, 5. And we're wanting to start with the one that had the greatest common divisor, which was line 4. So starting with line 4, we can say the greatest common divisor 1 is equal to, well, if you rearrange this, you can say that 1 would be equal to 7 take away 3 times 2. So 1 equals 7 take away 3 times 2. Can we do anything else with that? Well, no, we can't. So we go up a line, we go up to line 3. I'm going to say 1 is equal to, well, what we then do is we look at line 3, and we can see here the remainder is 3. So we are wanting to replace the 3 here with what it would be equal to if you rearrange this. So you can say that that would be 7 take away, and we would have, if we replace the 3, we can say 3 is equal to 10 take away 7. So that's going to be 10 take away 7 multiplied by 2. After this, just multiply out the brackets. So 1 would equal 7, that's not changing. We would be taking away, it would be 2 times 10. And we would be taking away negative 7 times 2. Well, the two negatives will make that positive, so it'll be plus 7 times 2. Gather anything that you can here. Well, you can see that you've got a 7 and you've got another 2 7s over here. So we've got 2 7s, we're adding on another 7, so really that's going to be 3 7s. So it'll be 7 times 3, and we're still taking away the 10 times 2. We would then go up a line, look at the next remainder. The next remainder was 7. So we would replace the 7 here with what it is equal to. So from line 2, we will say that 1 is equal to, and 7 would be 17 take away the 10 times 1. So it'll be 17 take away 10. We're still wanting to multiply that by 3, so put it in brackets, put it times by 3, and for this part here, well, 10 times 2 will just stay as 10 times 2. Multiply the brackets once again, so we've got 3 times 17. We are taking away 10 times 3, and we are taking away 10 times 2. After that, what could you do next? Well, gather any like terms. Have a look though at what your remainders will be. You can see up here there is a remainder of 10. So really you're wanting to replace 10, so gather the 10s together. So you've got a 10 here, you've got negative 3 of them, and you've got a 10 here, you've got negative 2 of them. So if you put them together, well, here you would have 1 equals, leave the 17 times 3, because we're really wanting to have that 17 there. We want to leave that. But we've got this negative 3 10s, and we've got negative 2 10s. So really, with the 10s, we would have negative 5 10s. So take away 10 times 5. Where do we go after that? Well, we go up to this line here where we replace the 10s with what they are equal to. So from line 1, we can say that 1 equals 17 times 3, take away. And with this here, we can see it's going to be 5 times and replace 10 with 231, take away 17 times 13. Close the bracket. After that, multiply the brackets. So we would have 1 equals 17 times 3, take away, and we would have 5 times the 231. We also have the negative 5 times negative 17 times 13. Now just remember, if you switch back, what we want to do is we're wanting to find integers x and y such that it's 231 and 17. So we're really wanting to leave the 231 and the 17, so we can leave this 17. So what we can do though is the 13s, we don't want them, so we can just put the 5 times the 13 together. We've obviously got the take away here, so the 2 negatives will make that a positive, and do 5 times 13, which will give us 65 times that 17. Again, we want to leave the 17 because we are wanting in our answer 231x plus 17 times y. So we need to leave this 17. Put the 5 and the 13 together, we don't want them, and it gives you 65. 2 negatives make that positive. After that, gather anything together. Well, you can see here, you've got 17 times 3, so we've got 3 lots of 17, and we've got 17 times 65, so we've got 65 lots of 17. Put them together, and if you have 65 add 3, that will give us 68 lots of 17. And we're still taking away the 231 times 5. We know we need this to be of the form 231x plus 17y. So what we will say is we've got 231 times by, well, what are we multiplying the 231 by? We're multiplying it by 5, but we've also got the negatives, so that'll be negative 5 that we're multiplying it by. We are adding on 17 times. What are we multiplying 17 by? Well, we're multiplying that by 68. And that would equal that greatest common divisor of 1. Therefore, x is going to be equal to the negative 5 because that's what we're timesing the 231 by. And y would equal 68 because that is what we're multiplying the 17 by. And that will be your answer. Try these in the Unit 3 booklet. You're on page 74. Check your answers as you go. But good luck using the Euclidean algorithm to express the greatest common divisor in terms of A and B. Woo! Good luck. Have fun. Bye.